Hi, I'm Paul Hopewell. Welcome back to my shed. Before I go any further, I want to say thank you to all my subscribers for your continued support, and I'd like to encourage those new to my channel to subscribe and click the bell. If you do like what you've seen, please click on the thumbs up. Also, if you've any suggestions or comments, let me know in the comments below. Thank you. In this video, I'm showing you how I made some alterations to the oilers on my milling machine. As you can see here, the front table slider oiler is easily accessible. If the oiler is not fully engaged on the slideway bed, the oil simply falls into the suds tray. The problem with the rear oiler is that it can only be accessed with the table in this position, so the oil falls into the tray. I drilled a hole in the power feed casing in an effort to access the oiler below, but the oil can only works in a horizontal fashion, not vertically as the oiler requires. Difficulties with the oil can are also a problem on the other end of the table as well. Dealing with the power feed side first, I plan to remove the oiler and replace it with a reservoir type oiler, ensuring that the bearing bush at this end gets properly lubricated. What you see here are my whiteboard jottings. I'm going to use brass for these, but the only brass I've got are a few hand-sawn scraps. I'm using the 4-jaw chuck to grip and manipulate the hand-sawn brass into visually the best position. Firstly, I'm machining the end face, that's to clean it up and to remove the rough surface. That done, I'll clean up the outside diameter. Providing it cleans up slightly bigger than 9mm, it'll do for what I need, and it looks like it'll do that. Because the material sticks out of the jaw quite a way, and because the jaws are only partly holding the material, I'll only take light cuts in an effort to help prevent any catastrophes. When complete, the material will be 9mm on this last cut. Now I'm cutting the 8mm spigot by 7mm long. This is a sharp high-speed steel cutter. It's set to 5 degrees. The lead is to guide the adapter into position, pretty much copying the original oiler, and is 2mm long. I'm using the 4mm drill to make the oil port before parting the adapter off to approximately 12mm long. The 9mm collar on this adapter will be drilled out to 5mm. When I sharpen the drill, that's better. Now a quick deburr, and here we have the first adapter. This is a bit of 1" by 3/4 brass cutoff. I'm going to use this for the oil reservoir. Again, I'm using the 4-jaw chuck to hold this material, and because the material is much bigger than I really need, I've set it up and trued it using a pointer only. Granted, it's not going to be a super accurate setup, and because there's such a lot of excess material on it, I'm not going to be too fussy about that. I did a little bit of facing off initially just to see where I am. Then I concentrated on turning the square material into something resembling round and clean before returning to the end face, just to get that out of the way. There was quite a bit of material to machine off this end face. Now that the end face is complete, I can now machine the material down to 14mm OD. That's going to be the main body and the lid diameter. Using a 2mm wide parting off tool, I cut a slot to 12.5mm diameter as a recess. Then, using my knurling tool mounted in the tailstock chuck, I knurled the edge of what is going to be the reservoir lid. Again, using the same 2mm parting off tool, I parted the lid off at 4mm long. This piece is going to be the main body of the reservoir. After facing off, I used a 2mm parting off tool and created a recess at 12.7mm diameter, half an inch, leaving a 2mm flange before deburring with a 45-degree tool. The next job is to centre drill a pilot hole for the 11mm drill so that I can drill an 8mm deep hole. Using the little boring bar, I machined out the recess to 12.6mm by 1.5 deep. This recess is to hold the lid in place, and it fits quite nicely. Using the same 2mm parting off tool, I parted off the reservoir to 13mm long, and after a little bit of fettling it should be ready for the next operation. I used the marking out blue to help offset the 5mm hole by 3mm that's got to be drilled in the bottom, and then I used my centre finder to make a line through the centre of this part. Then, using the odd legs set to approximately 3.25mm, and when I say approximately I mean at best guessed using the rule. The mole grips are my best way of holding this component at this time to prevent damaging the flange while drilling. This bit of 5mm copper pipe is a bit of brake pipe. I bought it specifically for this purpose. And when the parts are soldered together, the distance between the flange and the spigot shoulder on the adapter is 41mm. Looking through the power feed support bracket, you can see the oiler, the oiler that I'm going to remove. To do this, I'm going to use a large wood screw, drive it into the opening of the oiler, and use a claw hammer and a suitable support to lever the oiler out. Now I've got to try and install the newly made reservoir. It's a bit of a fiddly job, and I had to bend the pipe a little bit to align the adapter. Then it was a case of tap it into place, put a little bit of oil in it and put the lid on. The opposite end of the table still has a hand wheel. It's also oiled using the same kind of oiler. This also suffers from oil can starvation. That is, when the oil can is tipped up, it can no longer draw oil from the can unless it is brimmed. So I decided to make an oil reservoir for this end of the table as well. Using a bit of off-cut brass, the oil reservoir for this end is going to be a one-piece unit. The oil reservoir and the adapter as one piece. Here, after facing off, I made a 2mm spigot. Then, at 4mm from the face, I cut a 2mm recess to a nominal depth and used the knurling tool again for the edge of the lid. With the knurling operation complete, I parted the lid off. After a little bit of fettling, the lid will be complete. The first end of this oiler is done, and I've now turned it round to finish the other end. I'm still holding this part in a 4-jaw chuck though, and I'm clocking it true using the DTI. I used a 12mm drill for the initial cut to depth of 14mm. Then I used a small boring bar to finish the internal bore to size, which is 15mm, the same size as the cap spigot. I very lightly skimmed the top face, then machined a small spigot on the outside edge for no other reason than purely decorative, before deburring with a 45-degree tool. After removing the original oiler, I tapped the new one into place and filled it up with whey oil. After all that, I'm going to start the original task, which was replacing the oiler at the back of the table. At the back of the table, I'm going to replace the original oiler with a 90-degree offset insert to be fed from a pipe that's approximately 355mm long, about 14 inches, terminated at the end with a flared flange, so it'll only be a simple job. Making this adapter is going to be a similar process to the first one, except that there's no through hole. Instead, there's a hole at 90 degrees to the side. With the pipe soldered into the insert, it can be fitted. You can see here that the oiler is too close to the edge of the slide, and any oil that is pumped in simply pours out the end. This is where I removed the old insert using a screw and claw hammer over a suitably placed block for better purchase. Now it's just a matter of put the new insert into the old oil point and tap it home. I'm a little bit nervous about drilling into the table because I don't like doing it, but I have to hold the pipe in place. But I'm going to use P-clips and rivets instead of screws. I think I should have used a punch here for doing this. My aim wouldn't have won any prizes at a fairground. Well, it's fixed in place, and now it'll allow me to oil the table whatever position it's in. I'll decide at a later date how I'm going to finish the open end, but for now this is going to have to do. That's all for now. Hope you enjoyed, and thanks for watching. Bye for now.